Chapter 2 introduces cost behavior. If I'm going to manage and control my costs, I need to understand how various costs function so that I can customize my approach to them in an appropriate manner. There are three primary cost behaviors that Chapter 2 discusses, the first of which being fixed. A fixed cost behavior does not change as the volume of activity changes. Let's take a look at what this looks like. If I were to chart a fixed cost given some activity usage, in other words a quantity, and some dollar amount, then the chart would yield the following line. It's a horizontal line, and it basically tells me that regardless of whatever the activity is, the cost never changes. So the total dollar amount is constant, but I do know this. As I do more of the activity, the cost per unit is going to decrease. Let's just assume, for example, that this dollar amount is $1,000, and if I produce 1 unit, then that 1 unit must cover that full $1,000. Stated differently, that unit costs $1,000. If I do 1,000 units, then those 1,000 units share that $1,000. Therefore, each unit is only $1 a piece. So it's much more economical, it appears, to do more quantity because that fixed cost can be shared. And if we keep on this path, eventually the cost per unit is going to approach zero, which basically means that if you increase the quantity enough, your costs become negligible, and then everything is purely profit. Is this a great thing to motivate? No, it's not, because it creates what's called an economy of scale issue. It's nice to learn you've achieved economies of scale, but it should not be your goal to motivate your managers. Otherwise, you're going to wind up with misallocation of your resources. Case in point. Let's just say in order to drive this cost per unit, in this case, to zero, it may take 10 million units. If I can sell all 10 million units, that's great. However, it's highly unlikely that you're going to be able to sell the quantity it's going to take to drive it to zero. So your units are going to be sitting in a warehouse somewhere, and of course that incurs occupancy costs. So the cost per unit is zero, but it incurs other costs nonetheless. In other words, all economies of scale will eventually become a diseconomy of scale, and it's good to understand where that tipping point happens so you don't get into that diseconomy zone. But we can avoid that altogether if we just don't motivate managers on this cost behavior. Instead, we should focus on what is called a variable cost. A variable cost is going to change in total as the volume of activity changes, but it stays constant on a per unit basis. So in this case, if we were to look at this visually, we will see that there is a dollar amount again in some usage, but if we chart this, you can see that if you do nothing, it costs you nothing. But each subsequent unit is going to incur another increment of that cost. The benefit of this is the total dollar amount is going to increase, but your cost per unit is constant. And if I motivate someone on this, then I'm only going to do the units that are necessary, because one more increment will cost me one more, and I will just produce that which is most beneficial for the company. The third type of cost behavior is called a mixed cost. And this is a cost that exhibits both fixed and variable cost behaviors. And this one is rather difficult to control because you have two different kinds of costs represented. So if we look at the mixed cost this time, you'll see that it's going to start above 0. There's your fixed component. Plus, once you start doing activity, it's going to result in a cost per unit. So I can say this. The slope of that line would represent the variable costs, and the total dollar amounts will increase, but because there are more units sharing that fixed component, the cost per unit will decrease. But to manage this cost effectively, you're going to have to decompose this into the fixed and variable parts, and we will do that in the context of Chapter 2. So we can put all these together and come up with what we call a total cost function. And this is simply where your total cost equals your fixed plus your variable. Or stated differently, we could say your total cost is the fixed plus some variable rate multiplied by some level of activity. And we're going to use this to create cost functions. And the whole premise behind creating a cost function is that we can use it as a predictor for future costs that we may be trying to estimate. There are two primary means of doing this. There's something called the high-low method, which we're going to look at the highest activities and the lowest activities. And we're going to also focus on least squares regression. And this is going to not just look at two data points, the high and the low, but it's going to look at all data points. So we're going to look at some examples out of Chapter 2. We're going to start by looking at Exercise 14. Exercise 14 says that we have a hotel and we have some months worth of data for the number of days that we have occupants there. And we're trying to create some way to predict how much our custodial supplies expense will be. So we're going to look at our historical data to try and infer a relationship there in our quest for this estimator. The high-low method simply says look at the lowest and highest activities that were incurred. Of course, the activity we have is the guest days of occupancy. Once you've identified the lowest and the highest, then you will pick up the associated cost. You do not go back and identify the highest and lowest costs. Everything is keyed to the activity. Now, one of the assumptions of the high-low method is the lowest activity will yield the lowest cost and the highest activity will yield the highest cost. And that assumption did hold true here for Exercise 14. But please note, you do not identify the highest and lowest costs. You always do the highest and lowest activity and pick up the related costs for those two items. I'm going to take that change in cost and divide it by the change in activity. And for those of you who recognize this from, say, linear algebra back in your junior high or high school days, this is just rise over run, point slope method of a line. And this comes up to yield 75 cents per guest day of occupancy. Now I'm going to take this and use it to determine what the fixed costs are. High-low method is great because I can solve it in two ways and in the process check my work. We're going to take that relationship I just showed you a moment ago, that the total cost is equal to the fixed plus the variable rate times some quantity x. And you have two data points. And so if I look at the highest, the total cost is $13,500. The guest number of days is 12,000 and the rate is 75 cents. and I can solve for fixed. I'll do the same thing for the lowest activity using the 7,500 for the 4,000 at 75. And when you solve both of these, you'll note they yield exactly the same dollar amount, 4,500. So putting this together, we could say our total cost function is 4,500 plus 75 cents per guest day occupancy. Part 2 of this says, well, if we're planning on having 11,000 guest days, what should be our estimate of your custodial supplies expense? Well, just plug in that 11,000 into the equation, and you can see that it's going to be 12,750. Now, there's one word of caution that I have to give you here. When you use these cost functions to predict, they are only valid within the boundaries of the high and low. In other words, we create what is called a relevant range within these boundaries. And as long as you stay within those boundaries, then your cost behavior is assumed to remain constant. But if you step outside of those boundaries, the cost structure could change. For example, in this case, we wanted 11,000, and you can easily see it's between the high and the low. But if this problem had said 15,000, that is beyond the 12,000 here, and the entire cost structure could change. How is this so? Well, in order to go to 15,000, I may have to hire another individual to help me do some of the custodian's duties. And that would entail additional supplies. If I go below 4,000, it may not be even worth my while to hire a custodian to do these. I may outsource it, which would completely avoid all of these costs, and it would just be a fee I would pay to another company. So you need to be very careful to make sure you are within that range. Now, one of the things that we always do when we have data such as this, we try and visualize it just to see what it looks like. And so I've plotted this in part 3 here, and I've noted that if I connect the lowest activity with the highest and draw a line between there, that most all the other data points pretty much hover around that line, which tells me that the high-low method in this case is going to give me a fairly trustworthy estimate. Now, if there's a lot of dispersion in the data points, in other words, they're not very close to this line, then the results are going to have a lot of variability in it, and it's not going to yield quite as good results. Now, one other assumption of the high-low method is that the data is normally distributed. In other words, they shouldn't be all lumped at one end or up in a particular zone, and they shouldn't be bimodal, half down here, half up here. They should just be normally distributed throughout. But even with its simplicity, and that in this case it does seem to be functioning quite well, it is still limited in the fact that it only uses 2 data points. There is a better way in which to do this, and this is called regression analysis. You should have talked about this in your statistics class. Excel can also do regression. If you go to your data tab, you should have data analysis over here. If you do not, you need to activate it. Go to your file menu, go to your options, and then you want to click on add-ins. Go. And when you get this right here, you need to make sure that your analysis, ToolPak, and ToolPak Visual Basic applications are activated. And once you say they, with a click, then you will have up here on the data tab the data analysis. So I'm going to select that, and you can see in this list that it gives you all kinds of statistical things like correlation, descriptives, analysis of variance, F-tests, histograms. These are things that I know you should have done. T-test, Z-test, but the one we want is regression, so I'm going to click on that. And it's going to ask me for some data. So So I'm going to scroll up to my actual data here. And the Y over here, this represents your dependent variable, or in this case, the expense. The X is your independent variable, which would be your activity. What we need to do then is we can click here for a line foot plot, just to get a picture of it, and always make sure that your data is going to a new worksheet. If you don't, wherever your cursor is located, which for me is right here, the output would go right there and overwrite everything else. But if you send it to a new page, there's nothing for it to overwrite. And this is what it's going to produce. Now, I've taken this and cleaned it up a little bit to make it look a little bit more readable by widening the columns, highlighting some things. And this is exactly what was presented, the summary output. Key figures are those highlighted in yellow. First one being R squared. And in this case, it is 0.96, which can be interpreted as 96%. This is a measure of how much variability within the data the regression model has explained. In this case, it is explained 96%, which is an extremely high value. Think of it like this. The R squared can range anywhere from 0 to 100%. The closer to 100% you get, that can be considered ideal. But we need to be careful, because if you've only selected one or even two data points, you're going to get an R squared of 100% every single time. Why is this so? Well, one data point is going to be on this line. Two data points is going to be on this line, which means there's no variability. So you can't necessarily trust it if you get that 100%. You need to look at how much your data points are. In this case, we have 7. So I know I'm not going to have that problem. What I do then is look at what's called an F value. Now this is based on an F distribution, which is part of the model behind regression analysis. It's comparing the variation, in other words, the standard deviations of the points from the mean. Now, I'm not going to get into all the technicalities of that, but what I will say is this. You want an F value of 7 or more. In this case, it is a whopping 127, and look at the significance. Now, remember your alpha level that we typically use is like 5% when you did your t-test. I'm still going to use that here. But notice this is an exponent negative 5, which means this is 0.000000949, and so on. That's far lower than 5%, so I know that this is a trustworthy model. The next things I want to look at are what's called the intercept. This is your estimate of your fixed cost, and the X variable, that is the estimate of the slope of the line. And you can see, looking at a t-test, that variable is also very significant. It happens to be the exact same level as the f-test because there was only one variable used in this case. The intercept here is also significant, but I'm not really concerned about that. The dependent variable should not have a predicting effect on the costs. We're trying to look at something that would influence. So we just ignore the significance on the intercept. We're looking more at the X variable. Now, the graph that popped out is as follows. The little red boxes here, that's the regression predictor line. And then, of course, that solid one is the high-low line, and I drew that on the map, too. And you can see the regression lowered the line a little bit, and it's purely because it's trying to get this little blue data point here closer to the line. Remember, it's trying to minimize the variation. Take that and create your cost function. There's the fixed and there's the variable. Now if you notice, they are not the same as what we had under the high-low. If I scroll back up for just a minute, you'll see it was $4,500 plus 75 cents. This over here is $3,900 plus 77. When that regression dropped the line down, it lowered the intercept and it made the slope a bit steeper by dropping the lower end. And that's what happens. Now when I plug in the 11,000, it will be just like before. You can calculate it out. 12,476. And if I scroll back up, the high-low method was 12,750. They are very close together. This tells me that the high-low method is pretty good in this case. Even though I know the regression is much more precise, the high-low did very respectable. And that is purely because those data points were close to that line. Now if there's a lot of dispersion in the data, the high-low is going to be completely different in most cases when compared to the regression line. Exercise 11 uses a similar approach here. It's looking at shipping containers this time. And so I use the high-low method, identifying the 2 and the 8 as the highest and lowest. And using the approach I used before, I can come up with a cost function of $700 plus $250 per unit shipped. Looking at the line this time, you can see that there's a bit more variability in the data points. They're not quite as hovering to the line. And I went ahead and did another regression analysis, and you can see I only got 92% this time. But the F value is still highly significant, even though it's not that incredible 127 we saw earlier. It's only 59 now, but it's still significant at the alpha level of 5. And you can look at the data line here that regression put out, and you can see that the high-low, which is the solid line, and the regression are the red boxes. It kind of moved it uphill to get it closer to those data points. So when that moves up, it's flattening out the line, so the slope is going to decrease, but that's going to cause it to strike higher on the y-axis, so the intercept is much greater. So notice 700 plus 250. This here is 910 plus 217. And of course, following up this question, the regression is much more accurate, provides a better estimate. Now, I didn't just pick this one here just to go through another exercise of the problems. I used this one primarily for the fourth part, which says what factors other than the number of units shipped are likely to affect the company's shipping expense. Well, a lot of factors here could be the cost is going to highly depend upon the weight and volume of the units. And these were large air conditioners. So if I'm just going to have one of these, I may not need as large of a truck compared to if I'm doing 4 or 5. And also, not all units are going to be the same size, so the weight could differ. The distance is also going to be important. If I have to ship one several states over versus one within state, that's going to cause more transportation costs. And there should be deadlines that have to be made, or if our air conditioning went out and it's a heat wave, we need it as soon as possible. And so rush orders are going to require additional costs that we hopefully could have avoided otherwise. The next thing in this chapter deals with what is called a contribution margin income statement. Contribution margin income statement is basically focusing on these cost behaviors that we've started to address by looking at the variable and the fixed. So instead of a lumping of all costs together, we're going to separate them out according to behaviors. I wanted to look at problem 19 in your textbook. It says that we purchase pianos for $2,450, but we sell them for $3,125. And in this case, we sold and delivered 40. So I took the 40 multiplied by the price, 40 multiplied by the cost, and I can get what's called a gross profit. Now we have all these other costs here, and if you notice, they all have different kinds of behaviors. The selling cost was $700 per month, so that's fixed within this month. The salaries and commissions, well, they were $950 plus 8% of sales, so that's a mixed cost with a fixed component and a variable. The delivery was $30 per unit sold, so that's purely variable. Utilities is $350 per month, fixed. Depreciation $800 per month, fixed. Executive salary $2,500 per month, fixed. Insurance $400 per month, that's another fixed. Clerical is $1,000 a month plus $20 per piano, so there's another mixed cost, a fixed and a variable component. And then lastly, the depreciation was $300 a month, which is also fixed. Adding all those, I can get my total costs, and then subtracting that away, I get my operating income here. Now, part 2 says, break it down into the cost behaviors. Don't just list it in this manner. Show the variable separate from the fixed. And so that's what I did. I just recast it. I took the variable portions of the cost of goods sold, which was the amount we paid for them, the delivery expense, the sales commission, and the clerical, and then separated them from the fixed. Now, if you notice, those that were mixed before, the sales salaries, there is the other component down here, as well as for the clerical down here. Now, the end result you can see is still $8,000, but what this does is it highlights those which are variable, which are the ones we should be motivating managerial performance on because they can be easily controlled, and again those which are fixed, which we want to avoid that economy of scale. Doesn't mean I'm going to ignore them completely. It just means I need to be aware that the behavior matters. We're going to get a measure here called contribution margin, and that's the difference between sales and variable costs. And that's a key figure that we're going to see in subsequent chapters and topics. It essentially says, once you've considered all the variable behavior, how much do you have left to contribute paying the fixed costs and hopefully give you profit? Logically, you'd want to maximize this, because the larger you can make contribution margin, the greater potential for large profits you will have. And last part 3 is, why is it misleading to show fixed costs on a per unit basis? Now, I did that up here, and they're all those variable rates. But I didn't do any fixed cost per unit down here because it's not very meaningful. You change that quantity of pianos from 40 to 45 to 50, and these per units are going to change for the fixed. They won't change on the variable. So that's just not very meaningful when your cost per unit is in a state of flux. It also is trying to highlight that there are economies of scale that may be involved in. Again, we are trying to avoid those if possible. Now, there's another problem I have worked out, and I'll let you review this in your own leisure. This is case 2A-5. It's in the appendix to the chapter. And so it asks you to do high-low regression just as we did in class. So I'll let you take a look at that in your time.